great to be here today and to share with you some thoughts about the vulnerability of the North African fisheries and aquaculture communities to climate change. As Etienne said, I'm from Florida in the United States, Sarasota, and I work at Mote Marine Laboratory, which is a coastal lab. This is an aerial view of our main lab headquarters in Sarasota, luckily still standing after the terrible impacts that we saw in about 50 miles south of us from Hurricane Ian. I'm also the director of the Mote Aquaculture Research Park, which is one of our field stations for the laboratory. It's a 100-hectare facility with about 12,000 square meters of indoor aquaculture research operations. Our focus at my lab is on three key areas: designing, demonstrating, and transferring sustainable aquaculture system technologies, expanding reproduction, knowledge in reproduction and larval rearing and on-growing of marine species, both for stock enhancement and for food production, and supporting production of local high-quality nutritious seafood to educate the local community about the importance of aquaculture and the role that it plays in supplying our food. In terms of North Africa, fisheries and aquaculture make critical contributions to the economic development, to government revenue, to food security, nutrition, and health, and to the livelihoods of people throughout the continent. The FAO highlighted, as they do regularly, the proportion of fisheries and aquaculture production supplying our seafood. And you can see here that since the 1950s, that's where this graph started. And then we come up to 2018. We see that fisheries has leveled off in about the 90s, and that the expanded demand for seafood is now being met both through freshwater inland aquaculture and through marine, and this is continuing to increase, and right now we're at about 50% of this world's seafood coming from aquaculture. But if we go to the key topic today, which is the impact of climate change on fisheries and aquaculture, it's impacting it in two critical ways: rising ocean temperatures and increased CO2 in the water, resulting in ocean acidification. In terms of ocean temperatures, we see melting land ice resulting in rising sea levels, which impacts low-lying coastal communities and island nations. There's been a change in the strength and direction of currents, and severe weather events such as rainfall and drought and hurricanes. All of these seem to be increasing and becoming more extreme. There's been a reduction in ocean mixing, which impacts the nutrient supplies for phytoplankton, which support our ocean fisheries. And CO2 increase in the water impacts many organisms, especially the mollusks and the crustaceans. And we're still gaining a better understanding of the impact on fish populations as well. In terms of the specific impact on fisheries, it's in two key areas: species distribution and fisheries production. All species are adapted to live in a specific temperature range. And what we're seeing is that the warm water fishes are expanding toward the poles, while the range of cold water fishes is contracting into the cooler areas. We're seeing an expansion of nutrient poor zones, which impact food resources. And with fisheries production, we're seeing impacts on reproduction success, recruitment, survival, and growth. All of those are closely linked to temperature range. Reproduction in particular is highly sensitive to temperature. A shift of 1 or 2 degrees can change the timing on reproduction. And the total lifetime production, as well as the quality of egg production, is impacted by changes in temperature, especially if species reach maturity at a younger age, or if they spawn over a longer time period, you can result with lower quality eggs. Larval survival and growth is impacted by the availability of planktonic food and the currents that help them access that food resource. And then there's the increased risk of marine pathogens associated with increased bacterial growth at higher temperatures. An example of how it can impact reproduction, temperature changes. You can see here a graph. This is for a species that we work with here in Florida, the common snook, and it's showing the close link between spawning events and temperature. Here at this ideal temperature of 30 degrees, we see spawning occurring. Whenever the temperatures drop below that, spawning ends. And so this is how in aquaculture we cue animals into becoming mature and then spawning in captivity. And of course, in nature, as those parameters change, it impacts reproduction as well. In terms of the impact on aquaculture itself, we see extreme weather events and sea level rise resulting in flooding of inland and coastal farms. There's an increased chance of hurricanes or storms that can damage the infrastructure. And of course, in North Africa, we see impacts associated with droughts due to limited water supplies for small freshwater pond farming, and also increased salinity in coastal areas. Here in Florida, our oyster crops have almost disappeared due to increased salinity for species that are adapted to lower salinity conditions. An example of flooding impacts from Florida, Hurricane Matthew in 2016 resulted in the complete loss of the fish crop at Anguilla Fish Farm in Jacksonville, Florida, and that flooding destroyed the water pumping and aeration systems, and all the fish died. And this 30-year-old farm eventually went out of business due to the economic impacts of flooding and the cost required to rebuild and restock this farm. In terms of ocean acidification, we know that that's having a greater impact. It's being better documented every year on shellfish reproduction and on coral reef populations. We're seeing a decline in coral reefs globally associated with that increase in ocean acidification. And with the fishes, although it's far less understood, we are now seeing that there are impacts on skeletal development, especially in the early stages of fish development, on olfactory perception, and on neurological effects. So the evidence is coming in showing that we really need to address that. So what can we do to help to address that? I want to just touch on some things policymakers might focus on. One is to develop climate-proof infrastructure to help support fisheries and aquaculture production. A second area is to develop policies for management of fisheries that allow the diversification of fish resources for harvest. Instead of concentrating on just a few species, we need to actually spread out and look at smaller numbers of a wider range of species. We need to reduce fishing on sensitive species during the periods where they've been impacted, allowing them to recover and adapt to the changing conditions. Some species are more resilient than others, though. There is hope, as Naveen said. You know, I'm also an optimist, and concentrating your fisheries and aquaculture production on resilient species, those that are less impacted by these parameters, can help in this area. Expanding production of resilient species of corals for restoration is an area that our laboratory at Mote has been working on to help expand coral reef production in the Florida Keys. And managing and restoring coastal vegetation is a critical area that needs to be addressed so that we can protect those inland aquaculture areas. And so with that, I'm going to stop because I'm just 10-minute slot, so I'll stop from there. Thanks.
Right.